Welcome to GATE CSE. Today, we'll see the concept of determinant and its property. How to find determinant of a matrix and what are the properties which helps us in solving many real-world problems. Determinant. What is determinant of a square matrix? Say A belongs to R n cross n. This is the meaning. What is the meaning of this is if there are n cross n elements, a square matrix. So each of the n elements, n means n square element will be there. Each element will belong to the domain real numbers. That is the meaning. So you write is a scalar value. Scalar means you get some final one value. It's not a vector. There will be only one value will get scalar. Denoted by determinant A or like this, which gives important information about the matrix such as invertibility, volume scaling factor of linear transformation that we learn in vectors. So defined by that matrix A. So let us see how to find. So first to find that we need to understand the concept of cofactor. Okay, cofactor expansion. This is very simple. So here it is given mathematically. So for every matrix, the cofactor can be found out. For example, the cofactor is, say for example, this is the matrix. This is row 1. Okay, this is row 2. This is row 3. Now, what is cofactor says? Cofactor of ij. Let us take this element. Okay, I equal to 1. This j equal to 1. C of ij is equal to minus 1 power I plus j, okay, into m of ij. What is this m of ij? It's very simple. So first, this is the row you are selected, right? So except this row and this column, except this row and this column, whatever the matrix I get this, okay, sub matrix, this one, right? So this is the m of ij. Okay, n minus 1 into n minus 1. See, for example, this will be n cross n, that is 3 cross 3. This will be 2 cross 2. So that is how you find it. So for example, here minus 1 I plus j. So for the first term, I equal to 1, j equal to 1. So it will be 2. So it will be plus. The sign will be plus. Similarly, for the second term, here I equal to 1, j equal to 2. So it will be minus. And I take this, I will select, I will ignore this column and this row, and then I will get these elements here. So that is how you find the determinant. So you have to add that. Let us take an example. Okay. So sum of all those, that's what I told. Adding all those cofactors will give you the determinant of the matrix A. So let's see an example. So before that, we'll see some special cases. If there is only one element, n equal to 1, there is only one element, determinant will be that element itself. Next. Matrices of 2 cross 2. 2 cross 2 means will be only one cofactor I can get. Only one cofactor I can get. So that means, so if I select this row, then I cannot ignore. I will not get n minus 1 by n minus 1. So directly you can write this is the AB AD, that is this minus this AD minus BC. Okay. Similarly, 3 cross 3 matrix. 3 cross 3 means let us start with this first row A, okay, and first column element. So that will be A into, so 1 plus 1 is 2. So the sign will be positive only. EI, that means this submatrix. So you take the product and subtract cross EI minus FH. This. Then next will be second cofactor will be B. So minus 1 to the power I plus j I have to do, right? So this is 1, this is 2. So it is minus, this is 3. So minus 1 power 3 is minus 1. So I'll get negative. That's why minus B. If I take this B, so this row and this column will be ignored. So I have to take DI minus GF. DI minus FG or GF. Plus next it will be this element. Okay. This element is what? 3. I is 1 and 3. So it will be minus 1 power 4 plus value. So positive. Cofactor will be plus into C, and then you ignore this row and column, and then they only this submatrix. So DH minus EG. Okay. C into, that is how you find the determinant of A. That is the determinant of A, whatever you found out. So if there are, okay, so a simple example. So 1, 2, 3, 0, 4, 5, 106 is the matrix given. How will you find? So first 1 into determinant of this matrix. So I select this. So take this as submatrix. So determinant of this is 4 into 6 minus 0 minus 2. So this, the second term become minus because the cofactor sign minus 1 power I plus j will be negative. So minus this. Okay. So that is 0 minus 5. Minus 5 into minus 2 is 10. Then similarly the third one, this element, will get 22 as the answer. This will help us in finding the inverse. So similarly, example for 2 cross 2 determinant. Next, what is the, now we will see some properties. Okay, some 8 properties we have defined here. We'll see with examples. So it will be very helpful to understand this. It will be also helpful in solving. So what is the determinant of a identity matrix? Identity matrix already you know. Let us take identity matrix. So only the diagonal elements are 1, rest of the elements are zeros. This is the example of diagonal matrix I2. That is 2 cross 2 matrix, square matrix. So what is the determinant of this? It is 1 into 1 minus 0. That is 1. So for any identity matrix, the determinant of IN will be equal to always 1. Okay, this is the first property. A simple example is given here. So if you find out the determinant of this, you will get I equal to determinant of that I3, this matrix is equal to 1 always. Next, swapping two rows. Swapping two rows multiplies the determinant by minus 1. In the rank, when I explain the concept of rank or understand it, so we will see this. So let us take an example. So A equal to 1, 2, 3, 4. So determinant of A is, so A is 1, 2, 3, 4. So determinant of A is 4 minus 6, that is minus 2. Now swap the rows, swap these two rows. So B is equal to, if I swap this, so 3, 4, 1, 2. So determinant of A is equal to 6 minus 4, that is equal to 2. So this also applies for your any matrix, 3 cross 3 matrix. Okay. Multiplying a row here, multiplying a row by scalar k multiplies the determinant by k. So for example, let us see A is equal to 1, 2, 3, 4 and determinant we already calculated minus 2. Now multiply the first row by 5. So if I multiply the first row by 5, I get a new matrix A B equal to 5 into 1, 5 into 2, 5, 10, 3, 4. This remains same. Only first row I am multiplying by 5. Okay. So then determinant will be, what will be determinant of B? Determinant of B will be 20 minus 30. It is minus 10. So this is nothing but equal to 5 into, it is k. This is what I multiplied, k into determinant of A. Okay. Next, linearity in a row. Determinant is linear in each row separately. See, when I explain the vector concept, I will explain this again. What it means, let us take this example. Okay, so A is equal to 3, 3, 4, 5. Now, what is a vector? So if I consider only this row, okay, only this first row, this is called as a row vector. Okay, the vectors are also, you will see in the next videos, coming videos, what is the row vector and column vector introduction. So there we will explain in detail, but what is a row vector? To understand this property, row vector means to take in a matrix, each row forms one row vector, each column forms one column vector. What this property says, if I take this row and then say that just that row, I will not touch the second row. If I change, if it is sum of these two, if it is the sum of these two, if you add these two rows only, okay, I will get back this. This is a row vector. So then the determinant will be linear in each row separately. If you observe here, we calculate the determinant of A. This will be equal to -7, okay, plus 10, that is equal to 3. So that is, this determinant of this A will be, we calculate separately with the, for this matrix, this will be what? 15 minus 12, this is 3. But using this linear property of a row, adding two row vectors will give me the A vector for this matrix. Then determinant of A is, what is this? Determinant of this is 5 minus 12, is minus 7. Then 10 minus 4 is, sorry, 10 minus 0 is 10. This is what I am getting. Okay. So in general, if you remember this, this is not about addition. You don't get confused. Let us say there are three matrices or two. C equal to A plus B. Okay. Matrix C is equal to matrix A plus B. It doesn't mean that determinant of C is equal to determinant of A plus determinant of B. This is not correct. Not always true. Okay. Determinant of matrix C need not be equal to determinant of A plus determinant of B. Okay. So please remember this. Next. If a matrix has two identical rows, its determinant is 0. Why? Let's say 1, 2, 3 and 1, 2, 3. So when I explain again equilibrium forms, you'll come to know in depth. If you take the determinant of this same two rows, when you find the rank, you will see it. So this will give you the determinant of A equal to 0. This is the property. Next, transpose. Determinant of A transpose equal to determinant of A, because we are just changing the rows and columns. So the sum value, when I take the cofactors and add them, always the sum remains the same, right? So that's why whether you change rows or columns, the values, element values will remain the same. So for example, this is A. Transpose of A is given like this, changing rows and columns. We'll get the same determinant for each. Then the sum rule determinant will not work, I told you previously. But for the multiplication rule, it definitely works. Determinant of AB is equal to determinant of A into determinant of B. This is always true. So let us take determinant of A for A and B. Determinant you can find it as -2 and -1. So AB is equal to, if I take the product of these two matrices, this will be equal to 2, 1, 4, 3. Then determinant of AB, if I find out for this matrix, it is 6 minus 4. Okay. It is equal to 2. So here I got -2, -1. If I take the product of these two, multiply, I'll get 2. Okay. This is true for any matrix, any square matrix. Next, the important property is invertibility. If I want to find the inverse of a matrix, the next videos you will see how to find the inverse of a matrix if it exists. For a inverse to exist for a particular matrix, then the determinant of A should not be equal to 0. Because when you find it, you will divide it by the determinant of A. Okay. So for example, exams also may they ask, given this matrix whether it is invertible or non-invertible. So if the determinant of A is equal to 0, then it is not invertible. Is B equal to here 1, 2, 3, 5. Determinant of B equal to -1 is not equal to 0. Hence it is invertible. Okay. I am not a very simple concept. That's why I am a little bit going fast. So once we start the actual core concepts, then we'll see some very good problems and very tough problems. Okay, this is just to begin. Already you know this concept. Just to recap this. Okay. Thank you for watching. We'll continue in the next video. Please like, subscribe and share.